that if you have an I, you must also have its matching conjugate. So positive 2i. So this is definitely a polynomial of degree 3. As you can see, all the choices are degree 3. So we are going to write each one, since they called it f of x, I'm going to call it f of x. Since it's 3 zeros, I'm going to put 3 parentheses. X minus, x minus, x minus. And then I'm going to put each one of my zeros in right here. So minus a negative 1 is plus 1. Minus negative 2i is plus 2i. And then minus 2i. And again, you don't have a calculator, so you got to work it out. Okay, you got to actually FOIL it out. My dog's going a little crazy right now. I FOIL these two out first because they're honestly, conjugates are easy to FOIL out because you actually don't have to multiply the outside and the insides because they cancel. So you just have to do first times first, which is x squared, and then the last times the last. Positive 2i times a negative 2i is a negative 4i squared. But what is I squared? It's negative 1, and negative 1 times negative 4 would be plus 4. So these two together make that when you multiply it. And then you still have the x plus 1 on the outside, so you have to FOIL that out. So x squared times x is x cubed. Then x squared times 1 is x squared. And then you do your 4. 4 times x is 4x. 4 times 1 is 4. And that is your polynomial. So x cubed, x squared, 4x, and a 4 would be choice D. Let's do this one. This one doesn't have any i's, so that's great. But it has a 0, an x minus, a negative 1, a negative 2, and negative 3. So again, it's got 4, so it must be degree 4. So I'm going to write x minus, you can put 0, but really x minus 0 is just x. And then x minus a negative 1, which would be plus 1. Remember, you got 4 of them, so you write x minus, x minus, x minus. So now put the negative 2 in, it'd be plus 2. And then put the negative 3 in, it'd be plus 3. And you have to FOIL this out, okay, by hand, no calculator. You can do it. I probably start by bringing the x into this one. So let's see, this would be x squared plus x. And then I'd multiply it with this binomial. So that'd be x cubed plus 2x squared. And then x times x in the middle is another x squared. And then x times 2 is 2x. So let's see, that makes x cubed plus 3x squared plus 2x. And then I still have to multiply it by this x plus 3. So distribute the x to every single one of these and then distribute the 3. So let's see what we get. This would be x times x to the third is x to the fourth. 3x cubed. X times 2x is 2x squared. Then 3 times x to the third is another 3x to the third. 3 times 3x squared is 9x squared. And 3 times 2x is 6x. And then combine your like terms. And you'd get x to the fourth plus 6x to the third plus 11x squared plus 6x, which looks like it is choice A. So yeah, you're going to have to do some multiplying without a calculator, but you can do it. All right, then question number 3. Sorry for all my writing around it, but state the possible rational zeros for each function. Show synthetic division using the given zeros and find all the possible rational roots. So this is the rational root theorem that we talked about last class. So if you remember, that's where you have your P's and your Q's. You want to put your P, you want to find all the factors of P, and then find all the factors of Q. So P, the factors of P are, since it's a 1, it'd be plus and minus 1. For Q, all the factors of Q, what are all the factors of 3? Well, it would be plus or minus 1 and plus or minus 3. But now you have to write P over Q. So you have to put 1 over 1, which is 1, and 1 over 3. Now, if I'm looking at all my choices right now, it says I have possible rational choices. 0 plus or minus 1 plus or minus a third. This one has 0 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus... definitely not going to be B. C, 0 plus or minus 1 plus or minus a third. D, 0 plus or minus 1. Okay, so looks like I'm in the good, that I've got some choices with this. Now, normally, if you were allowed a calculator, I told you, go on your calculator and find yourself a 0. So that way you don't have to do all the synthetic division. But since I'm not allowing a calculator, you've got to do all the synthetic division. But I'm going to give you a problem just like this, where you can see there's not too many to divide by. You're just dividing by, look, 1, 2, 3, 4 of them, if maybe you don't have to, okay? So I'm going to start with, the root 1, and I'm going to synthetically divide 1 into here and see if that works. So let's see, it would go 3, 7, 5, 1, and then obviously there'd be a 0 number. And show your synthetic division, 1 and 10, 10, 15, 15, 16, 16, 16. Oh, I didn't get out a 0. If I didn't get out a 0, then 1 is not a 0. Cool. So that means I know my answer is definitely not a 1. So let's try negative 1. And to be honest, when I'm looking at all the multiple choices now, I can see, like, this one says negative 1 multiplicity 2. This one says negative 1 multiplicity of 2 down at the bottom. So I probably should have chosen negative 1 to begin with first, but we'll work through it anyway. Let's see. 3, negative 3, 4, negative 4, 1, negative 1, 0. Aha! I have my 0. So again, what did I just do? I just made a new polynomial of degree 3. Well, we found a root. That's awesome. It's negative 1. According to the multiple choice, though, it looks like I might have negative 1 twice. So you know what? I'm going to kind of use the multiple choice because you're allowed to. It's there. And I'm going to divide by negative 1 again, but I'm going to divide it into this new polynomial. I'm going to divide it into 3, 4, 1, and 0. And see if that works. So let's see. Drop down my 3. I get negative 3, 1, negative 1, 0. Aha, it worked again. So what did I just create? Well, this is now 3x squared. And you could stop right here and set that equal to 0. Remember, this is 3x squared plus 1. Set it equal to 0. 3x squared equals negative 1. Divide by 3 and take a square root. Oh, I know what I did wrong. I already know what I did wrong. I'm like, something's not working out right. This is not 1. This is 1x. See? This is why I'm like, I'm not going to get an I as my answer, so I knew something was wrong. So, sorry about that. I had to catch myself right there. This is 3x squared plus 1x plus 0. This is an x. This is not a 1 coefficient. This is the coefficient of x. So what I was just doing wasn't going to be helpful for me. So what I could do, though, is 3x squared plus 1x equal to 0. There we go. That's better. And I can factor out an x, and I'm left with 3x plus 1. There we go. That looks a little bit better. And then I set this equal to 0 and that equal to 0. So x is 0, and then 3x plus 1, 3x equals negative 1, x is negative a third. So there I go. I've got all my zeros. Negative a third, 0, negative 1, and negative 1, which means a multiplicity of 2. So when I'm looking at my choices, 0, negative a third, and negative 1 multiplicity of 2, and there's my possible rational choices. So it was definitely A. I caught myself there, and actually, I hope you do the same thing too, because if you catch yourself and you're like, why am I getting I's when there's no I's here? You know you did something wrong. So I just had to look back at my problem and be like, oh, there you go. So there's the first 3 questions on the non-calculator part. Let's do this part right here. For each function, state the maximum number of turns the graph could make. Determine the real zeros and state the multiplicity of any repeated zeros. It's the x-intercepts where the graph crossed the x-axis. And describe the end behavior. This is not as hard as it seems, honestly. I don't want you to be freaked out by this. You're like, oh gosh, but this is really what you've set your whole entire self up for. So we'll start with state the maximum number of turns. Do you remember turning points? So turning points is whatever the degree is, minus 1. 3 minus 1 is 2. That's the maximum number of turns that this graph can have. Number 2 says determine the real zeros and state any multiplicity. And then list the x-intercepts. 4 says describe the end behavior. I might do the end behavior right now because it's pretty easy to do. If you have a cubic, it's going to start down and end up. This is turning points. That's end behavior. So I know it's going to start down and end up. That actually helps me out right now because I know it's not going to be these 2 right here. This is starting up and ending down. Starting up and ending down. All right, and I am going to find some zeros now, okay? So if I'm looking at the graph, it crosses on A at -2 and at 0. And on B, it looks like it crosses at -2. So you know what? I'm going to use the multiple choice as a hint, since I've already eliminated 2 of them, and I'm going to synthetically divide by -2. So I'm going to synthetically divide -2 into this polynomial, which would be 1, 6, 12, and 8. And I'll drop my 1 and -2 and a 4 and a -8 and a 4 and a -8. Yes, and a 0. Perfect. So -2 is a 0. Well, based on these 2 graphs, this one crosses through once, which if you remember the rule about crossing through, that means you have an odd multiplicity. If you touch it like this one up here, if you just come up and touch it, then you have an even multiplicity. So I might just double check to see if -2 works again, because I have to check it anyway for this one, because this says the real zeros are -2 with a multiplicity of 3. That means it goes in 3 times. This one says it's -2 with a multiplicity of 2, so I'm going to try it. I know -2 works once. Let's try it again. And I'm going to try it into the decompressed new polynomial, which is a degree 2. So 1, 4, 4. 1, -2, 2, -4. Hey, it worked again. Okay, so it works. So this is now a decompressed polynomial of degree 1. So I might as well just set this equal to 0 right here. So x plus 2 equals 0, x is -2. Oh my, so that means I had -2 3 times. So my zeros are multiplicity of 3. So that's definitely the problem that I would choose, not A. Let's just make sure I answered. List the x-intercepts. As we know, zeros are x-intercepts. So you have listed them by doing this right here. And we describe the behavior. If you're in sketching the graph, you can just circle it because the graph is given. So part B, that is, answer is just B for number 4. So as you can see, it's not too hard. And I want you to use the choices. I want you to work backwards if you can. Use it to help yourself out. But you need to show some work. Definitely synthetic division is great. That will help you out a bunch. Okay, number 5. Approximate all the points of relative extrema of each function, then approximate the open intervals where each function is increasing and decreasing. Okay? So if you remember, extrema is just maxes and mins. Is it a max? Is it a min? Is it a relative max? Is it high point, but not really the highest point? Is it an absolute max, or it's the highest point on the graph? So when I'm looking at the graph that they've given me, and they will give you the graph, I can see that this point right here is it's a relative min, and this point right here is a relative max. It's a high point, but it's not the highest point on the graph. This point's higher, this point's higher. There's so many points that are higher. So I do know that it has a relative max and a relative min, and I'm going to call this, let's see, relative max looks like it's at 2, 2. And relative min is at 0, -2. So looking here at my choices, C says there's a relative min at 0, -2. There's a max at 2, 2. And then let's just double check that it's increasing, or it's decreasing from -infinity to 0. So let's follow my pen. It's decreasing along the x-axis up until 0 on the x. Then it increases between 0 and 2. And then it decreases again after 2. So it is increasing between 0 and 2 on the x-axis. These are x-axes. And it is decreasing from -infinity on the x-axis and from 2 to infinity. So yes, letter choice C. I would say for this one, there's not a lot of work. As you can see, I don't really have a lot of work. I just kind of labeled the graph that they gave me as which my relative max and relative min. Not a lot of work because I already gave you the graph to do, and I'll do the same on the test. So I'm just looking to see that you can actually interpret where the relative max and relative min are. Let's do number 6, excuse me. Same idea. Here's the graph of -8 over x squared plus 4. So look at that. I've got a point right here, which looks to be a low point. To be honest with you, looks to be the lowest point on the graph. But the test generator that I have didn't call it absolute. They just called it a relative min. So it definitely has a relative min right here at 0, -2. So looking at all my choices, the only one that has a relative min is A. And let's just make sure we read the rest of it to make sure it's correct. There's no max. That's true. There's no max, really. It's increasing from 0 to infinity. Here's 0 to infinity along the x-axis. Yes, it's increasing. It's decreasing along the x-axis from -infinity to 0. Yep, that's true. So A is the choice. Okay, so once again, 5 and 6, not a lot of work for those. I'm fine with you just writing the letters because you don't have a calculator, and that's all you need. But the last 2 questions, you do need some work right here for. And these are our last 2 questions for the test. And hopefully you'll feel a little bit more confident going into the midterm. Use the information provided to write the vertex form equation of the parabola. You must show completing the square to receive full credit. Yes, ma'am. Excuse me 1 second. Make a bouncy house right now? Adrian? Okay, you've got 10 minutes. That's it. And then come right back, okay? Sorry. Okay, so we are going to show the completing of the square of negative 2x squared plus 12x minus 15. So let me refresh you how to do this again. We've done it before on the first part. Now we got to do it again here. You're going to take that negative 15 and you're going to bring it over. And you're going to write y plus 15 plus blank equals negative 2x squared plus 12x plus blank. Now, we already have a problem, though. Do you see how there's a 2 right here? You cannot take the complete, you cannot do the completing the square unless you take out a negative 2 and make this a coefficient of 1. So we have to factor out a negative 2, which would leave us with x squared, but negative 2 from 12x would be negative 6x. And so that middle term of 6x is what I need to use to complete my square. Okay? So now let's do the completing of the square. So take a half of 6, which is 3, negative 3, excuse me, because it's negative 6. Squared is 9, but you don't put 9 over here. Why not? Because you factored out a negative 2. Negative 2 times 9 is what you need to put on this side. Negative 2 times 9 is negative 18. So let's see what I've got. So on this left-hand side of the equal sign, I have y minus 3. Negative 2 is pulled out. Rewrite this trinomial as something squared. What's squared? Well, it's x and then whatever you took a half of, minus 3. And then you're almost done. Just bring that 3 back over on that side. Y equals negative 2 times x minus 3 squared plus 3. That is the vertex form. If I'm looking up here, it's either B or C. Well, it's definitely not C because I didn't get a 5. So I'm going to go with B. All right, and then one more question. It doesn't really go with this direction up here. I don't know why the computer put it there, but it says, write a linear equation going through the points 5, 2, and negative 1, 4. When you go into calculus, if you so choose to, you really have to know how to write a linear equation. It's called the point-slope form. You need a point, which you have 2 points, and you need a slope. So the first thing you're going to do is find the slope. Slope is y2 minus y1 over x2 minus x1. So let's see, that would be negative 6 over negative 6, which is 1. So my slope is 1. Then pick a point. So I have a slope of 1, I have an x value of 5, and I have a y value of 2. And you put these 3 numbers, 1, 5, and 2, you put that into what's called the point-slope form. It says y minus y1 equals m times x minus x1. So you put a 1 in for m. This first x is left alone. The x that's 5 goes into the x1 value. So x minus 5. And then the y2 goes into the y1 value. So really, you can call those 1s if you want to, but it's y minus 2. And then you just solve it for y. So let's see, x minus 5 and then add 2 over. y equals x minus 3, which is letter choice B. Okay, I think that's it. Yes, those are my 8 questions.